Hello guys, and welcome to our channel. In this playlist we are going to explore the concurrent programming, but with a unique idea. So we are going to do some concurrent programming with Golang and then try to do the same thing with the Python. So from that you can clearly describe and see what's going on with Golang versus the Python. For that reason, I grabbed and found a nice YouTube guy. His name is Donald. I'm just going to go based on his idea. So he has this Go playlist with 26 videos, and the second and third video is about the concurrent programming in the Golang, and I'm going just to grab his idea and further improve it based on his implementation and explanation. I will put his playlist and the username in the video description, in our video description. Let's start. So what Donald tried to explain is just the order and refund process of say some e-commerce implementation or some sort of thing. So if you don't know Golang, just do not panic. It's not important at all here. But what we have here is a function, the main function, where we call the process function, and inside the process function we have this loop which is just incrementing infinitely, and it has a sleep like 0.5 0.5, right? And let's just run it. Let's see what's going on here. So go run main go. So processed order 1, processed order 3, and it's continuously just processing the orders. And how about if I want to refund the ordered products? So we are going to call with refund, and again run. So as you see, it never catches this refund function because it's just continuously running inside this infinite loop and never ends up to call this process refund function. That's the problem of the concurrent programming. So actually the simplest way. So in Golang, it's super easy to achieve this concurrency. You are going to just add this go keyword in front of the process, the function, and if you run, so now if you see, like, it's refunded, ordered, refunded, ordered, refunded, ordered. So it's just switching between this the functions. And this is actually how the base concurrency achieved from the Golang side. Let's see what's going on the Python side. So with Python, we have this the process function again. It has the for loop inside, the time sleep, again the printing the processed item, and we have also the main function which we are going to run here. If we run, so process 1, process 2, process 3, and etc. So it's the same thing if you try to refund here and rerun. It's never catch this refund the function, because again it will go through all the range, and whenever the for loop ends, it's going to process the refund. So that's not the case we want. Unfortunately, in Python, it's not easy as Golang, and we need here to implement this idea for concurrency. We need asynchronous programming, so we need async IO. And let's just start to implement the same idea with the Golang. So as you see, we want with Golang we want so refund order, and the same thing we want with the Python. But before this, we need to make this iterator actually as a generator, and it should be the asynchronous generator. That's why we are going to, first of all, to import asyncio and define this async generator. So async def async generator. It's my async generator, and it's going to it's going to range from here. Then it's going to yield our I, and of course we need to I think the sleep here, and actually await for this. Why we are not using time sleep but async sleep? Because the time sleep is blocking action, but awaiting the async sleep is asynchronous action, non-blocking action. That's our async generator. We need to make this process. Just scroll down here. This process function as well, the asynchronous. So make async def process item, and now we are going to not range, but we are going through this async generator, which is what's the problem here? It should be async for. Great, and we do not need this the sleep here. So what we did, we have created this async generator. We have created this async process, the function, and asynchronous for loop going through this asynchronous generator. What we need to do further to achieve our concurrency, we need to make this async the main function also asynchronous, and just register this functions as tasks, which is going to make them the features. So prior to Python 3.8 version, there is an ensure feature, but this is the async create task is a preferred way to do asynchronous programming in async IO with recent versions. And we have second task, which is refunding. And then we need to await these tasks, and we need to async IO run our main function here. As you see that we nearly rewrite all of our code in order to achieve the concurrency here, but still it's quite straightforward and neat. So again, just go through the code. We have generated the async generator. We have this process function with async for loop going through the asynchronous generator, and then we have a main function where we are registering actually our functions to be executed in the event loop. So if we run now this function, as you see, this refund order, and it's nearly smooth, like 20, 21, 23 order and 25, like it's going to the same amount. It's nearly similar to our Golang. So as you see, order, refound, order, refound, refound, order. But with Golang, it's just for some time it's just switching refound and the order. But with our Python implementation, it's the same thing. So we have achieved our first the plan. Actually, we did simple concurrent programming with Golang, and we did the same thing with the Python. In the next video, we're going to continue our talk about Golang concurrency problems, design patterns, and I will try do the same thing in the Python as well. Thank you guys. Thanks for watching. See you in the next video.